Alright, so we're into looking at how to determine the difference between a line graph or a column graph when you go to graph your data in experiment reports. So this data video we're going to be exploring this concept because really a lot of times kids just guess, right? As the cockatoo is testing my patience out there, right? They're very, very loud organisms. For such a small little body, they produce a lot of sound. Anyway, so a lot of kids just guess this, and it's not a guessing game. You can work the correct type of graph for the type of data that you have. And so if we look here, we can see this person's thinking, do I do a column graph or do I do a line graph? Now this line graph is a single line graph, but we can have multiple line graphs as well. But how do we know which one to do? Well, let's explore that. It comes down to what type of data you have. So when we talk about quantitative data, that is data with numbers, right, we can have discrete data or we can have continuous data. Now, discrete means that it happens in packages, in groups. So we can call this a group data. And so let's talk about shoe size. You're either a shoe 7 or you're 7.5, right? There's nothing in between a size 7 and a 7.5. You're either in one group, 7, or in the other group, 7.5. So that's data when it's grouped, and we call that discrete data. And when you do that type of data, that's when you have a column graph. Right? And that's when we look at the independent variable, right? What about the continuous data? Well, if you have continuous, it means you are along a continuum, a stretch, right? Which means that every single value is possible on your particular axis there. So let's say we are looking at temperature here. If we were recording the temperature of water as we heat it over 3 minutes, for example, and we chose to measure the temperature, and over those 3 minutes we recorded it every, let's say, 20 seconds. We could record the temperature every 20 seconds up until the 3 minute value. But we could also record it every single second or every millisecond. There are values along that X time axis that we could use. So it's a continuous data. If we're talking about temperature as an independent variable, we could be setting a solution at different temperatures and seeing how fast their reaction rate is. Well, we could measure it at 10 degrees, 20 degrees, 30 degrees, and then measure how much gas is produced, for example. But we could also measure it at every 1 degree, 10 degrees, 11 degrees, 12 degrees, 13 degrees. So that's continuous. And when it's continuous data, the independent variable, that means that we have a line graph. Okay, so that's what's going through your head. Every time you look at your data set, you need to be saying to yourself, is my independent variable, is it continuous or is it grouped? And the answer to that will tell you what type of graph to draw. So let's have a look at some examples here, right? So here I've got some situations which you have to decide whether it's a line graph or a column graph. And when you do this, when you press pause in a minute, I want you to think about, let's get my color pencils out and practice. What's the dependent variable? What's the independent? Remember, dependent is blue and independent is pink. Once you've decided that, you then have to say to yourself, okay, I've worked out the independent variable. Now is it continuous data or is it discrete data? And then you can decide what type of graph. So off to it. All right, let's see how you went. So if I now do my blue, which was the dependent data, it's what I'm measuring, the amount of salt in soil affecting plant growth. Well, I'm measuring plant growth, which means I'm determining the amount of salt that I put into the soil. So if I'm determining the amount of salt, I could be putting 5 grams, 10 grams, 15 grams, 20 grams. But there's a lot of grams there. It's continuous because I could put in 10.1 grams, 10.2 grams, 10.3 grams, right? So it's continuous, which means it's going to be a line graph. Okay, so let's do it in a different color. Let's go for orange. So it's going to be a line graph. Okay, all right. Next one, the mass of a fetus during gestation. Okay, well, what are we measuring here? We're measuring the mass of the fetus. What are we choosing to do? Well, we're measuring during gestation. So that could be measuring it every week, every month. So that's time. Okay, and so we're measuring time there, and that is a continuous quantity. So therefore, once again, we're going to be doing the line graph because the independent variable is continuous. How long it takes a car to stop in different brands of tires. Okay, so what are we measuring here? We're measuring how long it takes for a car to stop, for it to brake, And what are we changing? Well, we're changing the different brands of tires. Okay, so that means that you have one brand here and then you have a separate brand there. So that is grouped data or discrete data, which means it's going to be a column graph. Okay. How much energy is used in 1 hour of playing different sports? So what are we measuring here? How much energy is used in 1 hour of playing sports? Well, we're measuring the amount of energy that we use. So how much energy is what we're measuring? We are choosing to do different sports, right? So you're doing hockey, you're doing table tennis, you're doing football, you're doing gridiron, you're doing, swimming, different sports. So you're either doing one sport or another, so therefore it's going to be grouped, and so therefore it's going to be a column graph again, okay? Now, this little 1 hour statement, that's a control variable. You're just doing your experiment in a certain time frame, okay? The speed of sound in 2 different materials. Well, what are we measuring? Okay, we are measuring, and I'll change it to my blue again, we are measuring the speed of sound, but we're deciding to do it in 2 different materials. We're changing the type of material. What's the speed of sound in air? What's the speed of sound in water? What's the speed of sound in glass? So we are deciding to change the material, which means it's grouped data again, and so we're going to have a column graph. Okay, so by understanding whether it's continuous or discrete data, it'll make a difference. So let's check this one out here. It says a pupil used a sensor to record the change in pH of 10 centimeters cubed. Now remember, that is the same as writing 10 milliliters of an acid solution when an alkali solution was added a little at a time. His results are shown in the table below. Okay, so what is the independent variable here? What are they changing? Well, they're changing the volume of alkali. That's the independent variable, right? Notice it says added, right? They're adding it too. So he added 2 mils, and then he added 4 mils, and then 6 mils. So he's changing how much to add. He's deciding to do that, and then they're measuring the pH. So the pH is the dependent variable, okay? So therefore, if it's volume, it's going to be continuous data, because even though they added 2, 4, 6, 8 mils, they could have, if they wanted to, measure it at 2.1 mils, 2.2 mils, 2.3 mils, 2.4 mils. So it's continuous. There are possible values in between 2 and 4. So therefore, it's going to be a line graph, okay? And then you're going to have on your volume down here, which is going to be the volume of alkali, okay, and up here, and of course we put our units, right, centimeters cubed, and then up here in the blue, let's do it blue, we're going to have in our pH, okay, so that is for that one there. So hopefully now you understand how to decide whether it's a line graph or a column graph by looking at the X value, that is the independent value, and deciding if it's continuous or grouped. If it's continuous, what type of graph is it? That's right, it's a line graph, and if it's grouped or discrete, it's going to be a column graph. So make sure you got your details there. As always with your notes, you've got color, you've got key terms and highlighted, and I'll see you in the next video.